electromotive force, the most important thing we have to think about is battery. A battery is like, it's like a water tank or it's like a petrol fuel. It's like a petrol fuel pump. Okay, it is a source of energy, sumber tenaga. Okay, sumber tenaga. But the problem is, we are so used to the idea that the battery source, all the energy that is in the battery will flow inside the circuit. Okay, itu adalah cara pemikiran yang lama, yang sejak daripada sains dunia lah, tahun 5 ke tahun 6. Okay, you learn that, kamu pasang bateri terus ada current. Okay, but in physics, we have to consider this important thing, okay, which is the internal resistance of the battery. Okay, and the internal resistance causes a slight difference, okay, in the voltmeter reading. Okay, so all this is just everything is there. Okay, electromotive force is yada 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 yada, and I've already stated lah. And this is the important thing. Okay, in the past, saya sudah pernah cakap sebelum ini, I have said that the voltmeter kan biasanya kita pasang di sini. Usually we put the voltmeter over here, kan, with the constant wire or with the dial. Tapi itu adalah Ohm's law. When we put the voltmeter, okay, selari kepada battery, okay, we are not talking about Ohm's law anymore. That's why if you did the graph in page 113, you will find that both of the graph is voltage against current. In subtopic 3.2, the graph is voltage against current. This subtopic 3.3 is also voltage against current. It's the exact same graph, but why is the graph different? In 3.2, the graph is directly proportional, but in 3.3, the graph is decreasing linearly. Okay, so what kind of sorcery is this? How is it that we are doing the same graph but we get a different graph? Because in 3.3, we are not interested in the voltage that runs across the constant wire or the bulb. In 3.3, we are interested in the voltage that is running across the battery. That is the biggest difference that most physics students will always forget. Because they think, V melawan I, directly proportional, habis. Okay, cannot, V melawan I itu, V against I really depends on where you put the V, where you put the voltmeter. If the voltmeter is parallel to the constant wire, Ohm's law. If the voltmeter is parallel to the battery, electromotive force. Different concept altogether. Okay, cannot be the same. Okay, the reason why I'm very marah about, not marah lah. Okay, this is one of the questions yang as we get nearer to SPM kan, if you still don't get this by the time we hit SPM kan, memang saya akan teriak kan, sebab ini balik-balik saya akan cakap. Okay, voltmeter ditempatkan di tempat yang lain means that you are doing a different experiment altogether. Dia tidak sama dengan Ohm's law. Okay, so based on this, we find that when the switch S is open, okay, the light will be off. This is normal. Okay, the ammeter reading will be 0 because there is no current. Obviously, okay, there's no current. And then the voltmeter will be 3 volts, and this one is what we call the electromotive force. The total amount of energy that is inside the battery when there is no current flow. Sorry, so we find here that when when the switch is on, switch is off, or the switch is open, guys. Yeah, this is something that I think in the previous video I showed you. Switch on means switch close. Okay, switch tutup maksudnya switch dipasang, switch buka. Switch dipasang. Switch dibuka means the switch is off. Okay, because selalu kita buka lampu, tutup lampu, bahkan sebenarnya is tutup lampu yang tutup switch. Okay. This one, okay, yang berbahasa Melayu ini akan ada masalah dengan ini. For us is open the switch, close the switch. That's easy, Bahasa Inggeris is senang. Open switch, close the switch. Open switch means no electricity. Close the switch is electricity. Tapi kalau kita buka switch, tutup switch, lain bahkan. Buka switch means padam lampu. Tutup switch means pasang lampu. Okay, so dalam pengalaman saya kan, yang berbahasa Melayu ini yang akan menghadapi masalah fahaman ini. So you need to kind of adjust it a little bit lah. Switch buka means lampu off. Switch tutup means kamu kasih pasang lah. Okay, is lampu lampu on. Okay, and so we find that when there is current flow, the voltmeter reading, the energy inside the battery has reduced. Okay, so the E.M.F is the total amount of energy when there is no current flow. Okay, itu adalah fahaman biasa-biasa. Although the definition for electromotive force, if you fill this in, the definition is like super panjang lah. Work done to carry 1 coulomb of charge across the circuit, blah 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 blah. But our understanding, dari segi eksperimen, E.M.F is kalau kamu sambung the battery direct kepada voltmeter, that's the amount of energy inside the battery. But when current starts to flow out, okay, bila arus mula mengalir, okay, the battery is slowly losing energy lah. Okay, and we find that, oh, okay, there's 2.7. So the potential difference across the bulb, when the switch is closed now, over here, across the bulb, okay, it should be 2.7 because there is going to be a change over there. Okay, so this is what happens lah. What is the quantity? This is lah, E.M.F, this one. So the point is this lah, okay, the quantity of electrical energy released by the bulb. Okay, so this is what happens when there is no current flow, when the switch is open. Okay, bacaan voltmeter ni menunjukkan bacaan tenaga, the energy reading inside the batteries only. But when you close the switch, okay, the voltmeter reading, okay, will give you the reading of the entire circuit, which means that if I put a voltmeter over here, okay, it will also give me a reading of 2.7 volts. Saya faham because in this one it says across the bulb, which is technically correct lah, tetapi masalahnya in this experiment you didn't put the voltmeter across the bulb, you put it across the battery. Okay, but it basically means the same thing. Okay, if you put a voltmeter here or a voltmeter here, you will get a reading of 2.7 volts. So persoalannya adalah, where is the 0.3 volts? Dia hilang pergi mana? Okay, and in yesterday's video, I told you already lah, the 0.3 volts is the amount of energy to carry the charge from one end of the battery across to the other side. Okay, so the 2.7 is from here all the way to here. Okay, 2.7 volts. This is the amount of energy to carry the charge across here. Okay, and the 0.3 is to carry through the battery. Okay, kenapa? Because inside the battery, as I said in the video yesterday, inside the battery is chemicals. Okay, and at the molecular level, the electrons have to pass through all these chemicals, which is a lot of resistance. Okay, so in that sense, they need energy to pass through the resistance. Okay, so open circuit, closed circuit. This one, I think you should have, okay, inside of this one. Since nobody asked for it, so I'm going to do this one. Okay, so the difference between electromotive force and potential difference is this. I think it's, yeah. Okay, all this, since nobody asked for it, I'm just going to go ahead. Okay, ini sudah diberi, yada yada. Okay, so this one, so the E.M.F is 1.5 volts. Bila kamu beli bateri baru, okay, that nilai di sana is 1.5 volts. And semakin lama kamu guna bateri, it makes sense lah kan. Obviously, the amount of energy is going to decrease lah. Okay, so the voltage label on the battery actually it is E.M.F. Okay, cuma dalam, you know, when you go to the supermarket, right, you don't go and tell the supermarket auntie, auntie, can you give me a battery with the E.M.F 1.5 please? Slap your face. Apa E.M.F ini, okay? So, you know, only scientists use the word E.M.F lah. Okay, so let's be scientists. Okay, so different batteries obviously will have different E.M.Fs. Okay, a big 9 volt battery will have a 9 volt E.M.F. Battery in a car will have a different E.M.F. Even your phone batteries has their own E.M.Fs lah. Okay, but the E.M.F is the amount of energy that is able to be stored inside a particular battery. Okay, so all these are all examples of this one. Okay, so internal resistance. So what causes the voltage drop? Okay, is because of the internal resistance. So those of you who want the activity 2 reading, this is the reading. Okay, bila switch dibuka, when the switch is before the switch is closed, okay, is 1.5, energizer is 1.5. Okay, when you close the switch, okay, atau bila kamu pasang switch, okay, we find that the Duracell voltmeter is 1.4 and the energizer is 1.3. Okay, how I wish we are in school to do all this, okay, but unfortunately we have to do it online. So there is a voltage drop of 0.1 and a voltage drop of 0.2. So what does this mean? Okay, which brand of dry cell experiences a greater voltage drop? According to this reading, okay, the energizer has a bigger voltage drop. So why is there a difference in the voltage drop? Because the internal resistance are different for both brands. Who has more resistance? Obviously, it's the energizer battery lah. Because dia memerlukan lebih banyak tenaga, it needs more energy to cross over the battery. Wow, sorry. Why am I being so dramatic? Cross over the battery. Okay, to cross over the battery, you need a lot more energy. So energizer battery, okay, actually in this experiment, I'm not sure whether this is true or not. I like to use energizer battery. I have a friend that doesn't like energizer for some reason. So energizer battery, according to this experiment, has a bigger internal resistance. Dia punya bahan kimia di dalam itu memberi lebih banyak rintangan, gives more resistance to the electrons that want to flow past the battery, okay, from one end to the other end. So internal resistance, okay, is the resistance caused by the electrolyte in the dry cell. Okay, the unit for internal resistance is the same. Okay, it is also ohm. Okay, and I've already given you, I mean the textbook, or in my video yesterday, I've already given you this. So this is this one, okay, this one should be in your textbook lah. But anyway, internal resistance causes loss of energy. Okay, and that's why after a while when you use your battery, right, when you touch the battery will feel hot because there's a lot of resistance. Okay, this is something that I've said since chapter 4 last year. Resistance causes heat. Okay, rintangan akan sentiasa menyebabkan what is heat? Haba. Okay, bila dua orang bergaduh bahkan mesti keadaan itu jadi panas. Kan? Let's say if somebody, if you're annoyed or if you're angry at somebody, bahkan kamu selalu akan cakap apa? Ish, bikin panas. Nobody says, ish, bikin sejuk. Nobody says that, right? Okay, everybody says, ish, bikin panas, because resistance. Resistance causes heat, whether in electricity or whether in real life. Okay, if somebody annoys you so much, of course kamu akan rasa panas. Takkan kamu rasa sejuk bahkan. I cannot imagine if somebody, sejuk hati saya bila dia membuat saya marah. Kalau ada orang buat begitu kan, tolong bagi tahu dengan saya. Okay? Saya hantar dia pergi Bukit Padang. Manakah orang begitu? Okay, so loss of energy causes heat, and then the secondly is the potential difference across the dry cell will be less. Okay, so even though the battery has 3 volts, or even though the battery has 1.5 volts, not all the 1.5 volts will flow inside the circuit. Okay, and that is because of the internal resistance of the battery. Okay, how do you overcome the internal resistance? We have yet to find a way to do that lah. Okay, by using our normal battery. Okay, let me continue. This one is given inside your textbook, so I hope that you've done this. Okay, this experiment, I have given you the reading, right? And I've given you the reading. Have you all plotted the graph for this experiment? When I say have you all, means somebody just answer lah. Somebody.
Yes.
Okay, thank you. So Isabella is the representative of the entire class. Isabella say yes means everybody already answer. If you never answer, then it's your fault, okay? Not Isabella's fault. So once the reading is done, Okay, so this is the graph that you should get. Now, as I said just now, this is a graph of V against I. When we were doing 3.2, V against I was, astaga, V against I was a directly proportional graph, kan? That was in 3.2. This is Ohm's law. But now we are not doing Ohm's law. We are talking about electromotive force. So because of that, the graph will look like this. Okay? And if you followed the video closely yesterday, what is this value? This 3.0 actually represents what? Somebody? Oh, you know what? I'm going to call names. Ini 3.0 di sini nih. Kalau dalam graph kamu bukan 3.0 tidak apa, but in this graph, this 3.0 represents what? This 3.0
E.M.F.
Okay, I don't know what I do. It represents the E.M.F. How do you calculate the internal resistance by referring to this graph? Damir. Jangan-jangan Damir pun tidak. Damir, macam mana mau cari internal resistance?
Gradient.
Yeah, okay. Kamu cari the gradient. You find the gradient. When you have found the gradient, then you have found the internal resistance of the battery. But, okay, listen very carefully, and I'm talking about exam lah. If the question gives you a graph, you cannot use the formula to find the internal resistance. Nah, ni lah saya ganti I, saya ganti V, saya ganti E. Terus saya dapat R. Tak boleh. Okay, if the graph is given to you, you have to find the gradient, and that gradient equals the internal resistance. If the calculation is purely a calculation question, if the question is purely a calculation question, which we will see in page 114, then you use the formula. Okay, E equals to electromotive force equals to voltage reading plus the voltage drop. Okay. So according to this, if you have counted this, then you should be able to get this. So we find that the E.M.F is 3 and the internal resistance value is 1 volts per amp or 1 ohm. Okay, resistance is the same throughout, whether it is normal resistance or internal resistance. Resistance, the unit is ohm. So tiada masalah. Okay, I think activity 3 belum bagi bahkan. Okay, after this is activity 3. Okay, this one I explained in the video yesterday. Okay, if you haven't watched it, then guys, I can give you all the resources, but I can only membebel and meletir kamu untuk menengok tu video. So please watch it. Okay, activity 3, this is the one that Isabella requested. So this one is to study the effects of connecting dry cells in series and in parallel. Okay, so because this activity is not given, so we'll do this together. So in the first one, kita sambung dua battery like normal lah, satu depan, satu belakang. But in this second one, we pasang the battery one on top of the other. Okay, which means that if you are the current will flow here, will flow here, will flow here, and then will flow directly through both the batteries. Okay, manakala if the batteries are connected like this, the current will flow here, will flow here, flow here, will flow here. Sampai di sini, what happens? The current has a choice A or choice B. Or the current will split into two smaller parts. Okay, and dia akan melalui di sini. So if you think about this logically, don't even need to do the experiment. If you think about this logically, which arrangement has more resistance? Okay, it will obviously be the first one because the current has to flow through both batteries. Dia terpaksa melalui kedua-dua bateri. Okay, to come out the other side lah. Manakala this one dia seperti berat sama dipikul, ringan sama dijinjing. Okay, you go here, you go here. So we each carry the burden. Okay, so we find that in a parallel arrangement, the internal resistance is lesser. Okay, but okay, so this is the reading lah. Okay, you can jot down the reading. So in a series circuit, the E.M.F is 3 volts. In a parallel circuit, is 3 volts. Okay, the E.M.F is the same because it's 2 batteries. Okay, but the potential difference, we find that in a series circuit, the potential difference is 2.7. Okay, when I pasang the switch, it will become 2.7. Manakala in Solari, it becomes 2.9. Okay, and the ammeter reading is 0.5, 0.6. Okay, ini diberi tiada pengiraan ini. Sepatutnya diberi kalau kita buat ini eksperimen lah. Okay, and we find that the total internal resistance or the effective internal resistance in a series circuit, okay, this will be the calculation. We use the same formula. Okay, E equals to V plus I R. Okay, so the E is given 3. Why is this 0.3? So weird. Okay, V is this one and then I is this one. Then what you do is you can count the R. Okay, you count the R. For this one, it will be 0.6. For this one, it will be 0.7. sekaligus membuktikan bahawa in a series circuit, the effective resistance is higher. In a parallel circuit, where the batteries are arranged in parallel, okay, the effective resistance is lower. Okay, so the question, which arrangement of dry cells produces a smaller effective resistance? It will be the arrangement in parallel. Why? Okay, why? Because the current is bigger. And this brings to mind, this brings us to a very, very important relationship. Okay, 5 seconds take a screenshot. I need to move on to the next one. Sebab saya punya niat asal ni bukan untuk membincangkan ni. I want to talk about the exercises. Okay, 4, 3, 2, 1. Okay, so this is the important thing that we need to understand. Okay, this is the important thing that we need to understand about when we arrange battery in series and when we arrange battery in parallel. The good news is, in parallel, the effective internal resistance is smaller. Okay, but the problem is the E.M.F remains the same. The amount of energy is still the same, still one battery, same as one battery. If you arrange the batteries in series, seperti yang kita biasa buat lah. Okay, you put the battery inside the torchlight, is arranged in series kan, kita letak satu, lepas tu satu lagi. Okay, even in the school lab, okay, even in the school lab, when we do experiments kan, we arrange the batteries in series. So the good thing is, we have a bigger amount of power. Okay, kalau setiap satu adalah 1.5, 1.5, 1.5, 1.5, the total voltage will be 6 volts. 1.5 kali 4. But the problem with this is, the current has to go through every single one of this battery to come out the other side. So dia punya resistance, dia punya internal resistance adalah sangat tinggi. Okay, so the question is, what situation? Okay, we know that batteries in series is good for situations like torchlight lah. We want that. Okay, we definitely want a torchlight to be in series because we want a lot of power. Okay, the question is, what kind of situation would we want the batteries to be arranged in parallel? Okay, I wonder if, tiada pula kan dia suruh kamu. Okay, so this is the thing that I want you to kind of do a little bit of research on today lah. Maybe in the next class you can tell me. What kind of situations do we have in our world today where we need our batteries to be arranged in parallel? Series is very easy. Series we always see. Battery lah, remote control car lah, remote control airplane lah, drone lah, semua ini kan. Okay, sorry, drone is rechargeable kan. I mean, most of the time series is very easy. Okay, tapi ini yang saya mau kamu fikirkan. What kind of situations where, bagus kalau dia punya battery disambung secara selari. Okay, go and research this and put it up in our group so that people can also learn from this. Alright. This is the thing that we want to do today. Okay, the activity 4. Okay, please turn with me to page 114. Diagram shows a cell with E.M.F and internal resistance 1. Sorry, E.M.F is 2 volts bahkan, according to this one. 2 volts. Internal resistance is 1 ohm, connected to a resistor of 4 ohms. What is the reading on the voltmeter when it is connected across the 4 ohm resistor? Okay, so let's take a look at this. Okay, the reading across, we first have to find out what is the current flow. Okay, we have to find out what is the current flow. So when we use this, since we don't have the V, we use the alternative one. Or, saya punya pen tiada di sini. Or if you want, you can use the method that I taught in the video yesterday lah, which is E, equals to V plus the V, is it the V drop? Yeah, the V drop. Okay, you can count each separately and then after that you can put it together. But if you don't want, you can use this formula, E equals to IR plus R. The big resistor is 4 ohm, small resistor is 1 ohm, okay, and the electromotive force is 2. Okay, then you can count the voltage that is running across here. Okay, and so you will get first you will get the current. Once you get the current, then you can count the voltage running across here, which is 1.6. Okay, another way that you can calculate this, kalau kamu mau guna cara yang saya mengajar yesterday in the class, okay, yesterday I taught you that if you want to use E, okay, the electromotive force equals to the voltage, Ohm's law, plus the voltage drop. Okay, the V drop. E is 2, okay, the voltage we don't know lah, okay, but we know that it is 4 times I, okay, according to Ohm's law. The voltage is 4 times I plus the V drop is the current times the internal resistance. Okay, so it will be 1I. Okay, so 2 equals to 4I plus 1I will be 2 equals to 5I. Okay, and then you will get this one, the I equals to 0.4 amps. This one, memang no choice lah. You have to figure out what is the value of V. Okay, because the question is what is the reading of the voltmeter, which is the big V. Okay, I usually like to teach the way I taught in the video yesterday lah. Take it out separately and then chuck it together at the end. Because once you know the relationship kan, is much better than memorizing the formula. The formula is just honestly, the formula to me is very confusing. Some people like the formula. Okay, next question. Bulb M is connected to a battery, okay, by means of a switch. A voltmeter is connected across the battery. Okay, so this is a key word. Across the battery means we are talking about E.M.F already. We're not talking about Ohm's law. When the switch is open, the voltmeter reading is 6.0 volts. So this 6.0 volts refers to your E. Okay, how do you know that it is the E.M.F? Because of the words when the switch is open. Switch is open is keadaan begini ya, switch dibuka. Okay, this is a real complication. Kalau yang biasa cakap bahasa Melayu yang standard bahkan switch tutup switch buka, sekali dalam bahasa saintifik switch tutup switch buka lain pula maksudnya. When the switch is closed, when the switch is closed, tada, okay, saya kasih sambung. The reading is 4.8 volts. That means the V is 4.8 volts. Okay, what is my voltage drop? Adam, what is my voltage drop, please?
Which question, sir?
No question. I'm asking you a question which has nothing to do with this. I'm asking you if the electromotive force is 6, when you pass on the switch, okay, 1.2. The voltage drop is 1.2 volts. Okay, so question A, what is the E.M.F of the battery? Obviously, it's going to be 6 volts lah. Sorry. Okay, if the resistance of the bulb is 8 ohms, what is the current passing through? Okay, if the resistance over here is 8 ohms, okay, how do we count the current? Do we use 6, do we use 4.8, or do we use 1.2? Which one do we use? Michelle?
We use 4.8.
Okay, very good. We use 4.8 because the voltage drop doesn't happen in the bulb. The voltage drop happens in the battery. So when we use 4.8, we are going to get 4.8 divided by 8. Okay, we use Ohm's law, V over equals to IR, and we will get 0.6 amps. Okay, and as I said yesterday in the video, current flow over here, kalau sini 0.6 amps, sini pun adalah 0.6 amps. So can I find the internal resistance of the battery? Can, but this time we use the voltage drop. Okay, to find internal resistance, we find the voltage. We use the voltage drop punya voltage, and that's where we sorry, this is so nonsense. 1.2. So 1.2 divided by 0.6, which is the current you found in question B, you will get 2 ohms. All right, question number 3. When the switch S is open, the voltmeter reading is 1.5 volts. Okay, same thing, 1.5 volts. What does this refer to? E.M.F, voltage, or voltage drop? I'm running out of people to call already. E.M.F, Brandon. 1.5 volts. E.M.F, voltage, or voltage drop?
E.M.F.
Okay, 1.5 refers to the E.M.F. When the switch is closed, the voltmeter reading is 1.35 volts. Okay, this refers to the voltage. So, Angeline, can you count for me the voltage drop, please? How much is the voltage drop?
0.15.
Okay, very good. 0.15. Okay, let's bear this in mind. Voltage drop is because of internal resistance in battery. Voltmeter reading is because of the resistance in the resistor. Okay, so calculate the E.M.F. No need to calculate, it's already given. Okay, understand the situation. How do we calculate the internal resistance? We have the current and the voltage drop. Okay, what do we use? We use V equals to IR. Okay, can somebody please calculate this, please? Voltage drop and the current. Calculate the internal resistance for me, please. Okay, calculate, and let's have Elijah. Can you answer this, please? How much is the internal resistance?
0.5.
0.5. 0.5. Internal resistance is 0.15. Sorry, the voltage drop is 0.15 over equals to 0.3 times R. 0.5 ohms. Okay, very good. I should have brought out my pen today. Okay, so what about the big resistance? Which one do we use to calculate the big resistance? We use the voltage reading. Okay, can somebody please give me, no, not somebody lah. Let's have Jacinta. Jacinta, reading of the resistance, please.
4.5 ohm.
4.5 ohms. Okay, can you tell me the calculation?
1.35 equals to 0.3 R, and then divide 1.35 divided by 0.3.
Okay, very good. A with 0.3 R. Okay, so remember, I mean, this actually the calculation for this part is very easy as long as you remember one thing: the current flow is the same. So you just use the same current all over again because everything is connected in series.